Hello everyone, and welcome to the Getting Started training session on MotorWizard, where we will design and analyze a surface-mounted permanent magnet synchronous motor, PMSM. This training is designed to help you get started with the essential steps in creating and analyzing motor designs using our MotorWizard software. Part 1. Setup Design. Let's begin by launching the EMWORKS software. To do this, simply double-click on the application icon and give it a few moments to initialize. Once the start screen appears, you'll see the project manager tree on the left-hand side. This is where we'll organize and manage our design. In the project manager, right-click on Projects and select New from the drop-down menu, followed by MotorWizard. This will prompt you to enter a name for your project. Feel free to use a custom name or training project for simplicity. Once your project is saved, we're ready to create a new motor design. Right-click on the project name, Training Project, and select New Design. From the options provided, choose Inner BPM, which is an inner rotor brushless permanent magnet. At this point, MotorWizard will generate the design, and a new window will open. If the design window isn't positioned correctly, don't worry. You can easily reset it by clicking Restore Default Docking on the ribbon at the top. Now, let's dive into the design setup. Go to the Model Settings tab in the EMWORKS Manager on the right side. We'll begin by entering the rated parameters and general sizing values for this motor. Next, we'll move on to the stator design. In the stator tab, adjust the core and slot properties according to the following parameters. Under the stator core properties section, input the specified values. For the slot properties, select General Square Slot from the drop-down menu and adjust the dimensions. You can also take advantage of the live preview window, which will allow you to directly visualize any modifications you make to the stator design. Now let's proceed to the rotor. Click on the Rotor tab, where we'll adjust the core and magnet properties. For this motor, we'll use surface-mounted radial magnets. Make sure to select Surface Radial Magnet in the Rotor Type drop-down and input the provided values for both the core and magnet properties. For the winding configuration, click on the Winding tab. We'll keep the default values here, but if you want to visualize the winding layout, simply click View Layout Table and Show Winding to preview the winding pattern. Next, we'll configure the coil properties. Make sure to set the fill factor by checking the Set Fill Factor box. Once the winding is set up, we'll move on to the material selection. Click on the Materials tab and choose the required materials for the motor parts. For example, to change the magnet material, right-click on Magnet Material, select More, and navigate to the Material Center. From there, expand the Metals category, choose Permanent Magnet, and select NDFAB, specifically, the N4212 material. Part 2, Analysis. Now that our motor design is complete, we're ready to move on to the analysis. We'll start by running the performance analysis. Right-click on Analyses in the project tree, select Analysis, and choose Performance. A new analysis will be added to the project tree as Performance_1. In the MZ Manager, you'll find the analysis settings. For this training session, we'll keep the default values. Once ready, right-click on Performance_1 and select Run. The software will begin solving the performance analysis. Next, let's set up the onload analysis. Just like before, right-click on Analyses, choose Analysis, and select Onload. This will add onload_1 to the project tree. In the analysis settings for onload, check the Compute Iron Losses box, but leave all other settings unchanged. Once everything is set, right-click on onload_1 and select Run. MotorWizard will start the solving process, and soon you'll have the results of your analysis. Part 3, Results. Once both the performance and onload simulations are completed, it's time to review the results. You can access all the results from the Results Center. To open the Results Center, simply right-click on Results in the project tree under the Analyses section. A pop-up window will load, displaying the results for both analyses. To efficiently analyze and compare multiple outputs, you can enable Panes Mode from the View tab on the top ribbon. This feature allows you to view several plots simultaneously. For instance, you can hold the Control key and select the following comparison plots. From the Performance Analysis, select Torque versus Speed and Power versus Speed. From the Onload Analysis, select Torque and Winding Flux Linkage. To dive deeper into the Results Center, you can explore other features. For example, click on Back EMF under the Onload Analysis. If you prefer an alternative layout, you can switch to Window Mode for a different display format. To analyze the data in more detail, select Curve Data, which gives access to the numerical data for the back EMF curves. You can also fine-tune the visuals. Select Back EMF Phase 1, and change the line thickness as desired. Check the box for Show Marker and select the marker type as Square to make the plot clearer. For those who prefer working with data tables, you can easily switch to Spreadsheet mode by clicking on the icon located at the bottom left of the window. Once in Spreadsheet mode, Load all the result data by selecting onload_1 from the project tree. To focus on specific data, select torque to view its data and waveform. You can even modify the plot's visual style. Click on the Change Chart Type option from the ribbon under Chart Tools, choose Clustered Column as the chart type, and confirm by clicking OK. This will update the waveform accordingly. Finally, to visualize the field plots, return to the MotorWizard main window. Right-click on B and select Show under the Field Plot section in the project tree. This will load the magnetic flux density field plot for the motor. In the MZ Manager on the right side of the screen, you can adjust the field plot settings. For example, modify the min-max range to go from 0 to 1.8 Tesla. This helps identify saturation areas within the stator and rotor cores. You can also increase the plot's resolution by changing the number of contours from 10 to 40. This concludes the Getting Started training for EMWORKS-MotorWizard. In today's session, we've covered the fundamental workflow for designing and analyzing a surface-mounted permanent magnet motor. We explored every step, from setting up the motor design, running performance and load analyses, to visualizing the results and field plots. To continue learning and mastering MotorWizard, be sure to check out our YouTube channel, where we have a dedicated playlist for MotorWizard tutorials. You can also explore additional resources on our website. If you have any questions or need further assistance, don't hesitate to contact us. We're here to support you.